Hello, all, and welcome to Rust for C Engineers series. The entire series is designed to help C engineers migrate to Rust. It also helps build very strong fundamentals on Rust and helps easy migration. To give my introduction, my name is Rati Karthik, and I have more than 20 plus years of experience in C and C, predominantly in embedded and systems programming. I'm currently working for Microsoft Corporation, Mountain View, California. Earlier, I was with Juniper Networks, which is now HPE, and before that, I was with Wipro Technologies in India. And I'm really grateful for all the companies who have given me the opportunity to learn and contribute. And that learning is something I'm bringing to all of you. I'm also the author of book Rust for C Engineers, and the content of the entire course or series is based on this content of the book. The link for this book will be shared in the description box. So now coming to the layout of the class, because Rust is a language, it has both theory part and it has coding part. The theory part definitely will be covered through PowerPoint presentations, and the programming also will be addressed as separate coding sessions. And the coding also is made as interesting as the PowerPoint. Okay. Yeah, so one request is that when you're watching the course, please watch them as a series, because every video, the current video is always dependent on the previous one conceptually, right? So if one video is built on top of another video, so watching them in a sequence will make you understand stuff. Okay. So coming to C, C has ruled the embedded industry for more than several decades, right? So, and in embedded systems, it has occupied more than 75% of the industry, and rest of the 25% is other languages like Python, C++, Rust, Java, some assembly and other code, right? So why are we learning Rust? Can we not learn Rust standalone? Why do we need to learn Rust in with C context? Okay. So just to give my own personal story. So when I was learning Rust for the first time, working on the Rust project, I felt it as a very frustrating experience, very frustrating, and I literally hated Rust. It felt so straight, you know. I was wondering, why do we have to do in Rust? C is so good, so C is so easy, and C is so dominant. Why do we have to do this? Okay, so this entire series is basically my journey of learning Rust, and every concept that I wrote in Rust, I had to map it to C in my mind. Hey, how does this work in C? And is it only a syntax difference, or is it there is much more to it, right? So every concept was basically a fight within myself, and there was a kind of resistance in me not to learn Rust. So that resistance is definitely broken with this entire course. And as I was learning Rust mapping to C, I found Rust as one of the most safe languages, right? It still doesn't take out my love for C, because that's something I've worked with day and night for so many years. But Rust is definitely extremely safe language, and I'm so proud of Rust. Right. So this is because because he has occupied more than 75% of the industry. I assume there are many engineers like me who are literally struggling in their minds to learn Rust. Okay, and this entire course is built to break that resistance and welcome Rust very openly. So at the end of the course, you'll definitely fall in love with Rust, and also you'll definitely your love for C anyway remains, right? So one more thing is that caveat is that we are going to highlight problems of C in almost every concept going forward. That's not to degrade C. That's basically to showcase problems to and to make sure that why rust was a solution, right? Why rust was a solution or a response to C's problems, right? So we don't want to highlight one and put the another down. So it's just that we want to make sure that they are both are complementing each other. So C has predominantly ruled the industry and given great control over memory to programmers, right? But however, we all know that C has a lot of issues when it comes to memory safety bugs or pointer misuses, segmentation faults. We have all debugged all of this late night, right? And concurrency issues, we have so many, right? So these are not theories. So all of us have worked using different debugging tools, and they are observed in production systems. So when the rust problems are basically clear, then we know that see how rust is, when C problems are clear, we know how rust feels inevitable or good. Okay, so in the entire series we are not going to learn only the syntax differences, we are going to learn rust in a very deep way which will have a very long lasting effect on us. So Rust is basically an evolution of C, okay, not a competitor, right? So Rust, if you learn in isolation, so you might literally feel it very strict unless you do not have not worked on C, right? But if you have worked on C, then this method definitely works very well for all of us. So before we start, right? So we have to give tribute to the founder and know the history behind it, right? So Rust was originally created by Graydon Hoare. Okay, so Graydon Hoare, basically around 2006, he was living in Canada and basically in 21st floor, right? So the elevator in his apartment has had a habit of breaking or malfunctioning. It would occasionally stop functioning and would require a reboot or so that it could be used again. So then basically, Graydon Hoare thought to himself, like, why do these ordinary machines like elevators still crash? And they were not hardware problems, they were basically software problems, right? So whenever such a problem happened, there was a lot of inconvenience, like all of them climbing over the elevator, the staircase, right? So imagine young people can do, how about small children or elderly adults and who do not have strength to climb, right? It's definitely very, very inconvenient. So to add to this, even I myself was stuck in an elevator many years back in India with my little one. My little one is around 1.5 years old, and that time it was not automatic generator or backup. Somebody had to go, security guard had to go and turn on the generator for the elevator to start. And that moment of 5 minutes to 7 minutes, it was definitely a huge panic, right? And that panic definitely made me not go through elevator for next 6 months, right? So it can definitely give a lot of panic attacks, because people inside the elevator won't know if it's a hardware fault or it's a software fault, or even the security guard is there or not to power on, right? So it can be a huge it can be a huge risk. So some problems in software are inconvenient. For example, vending machine, right? Vending machine, coffee vending machine, if coffee is not rendered, it's an inconvenient problem, right? We can go outside and buy coffee from Starbucks, or just be without coffee and adjust for that day. But some problems, like braking system failing in aircrafts, like both the redundant engine and the main engine, right? It's hazardous. Similarly, electric vehicle completely automatic brakes in the middle of the road, right? The braking is locked. What do you do? It can definitely give a lot of a big panic attack to the person sitting there. And some of them are very hazardous. For example, a malfunction in temperature control system, if it is not working, it can cause a fire hazard, right? So many of them, many software can cause lot of plenty of safety hazards. Also all the robotic health monitoring systems, or nowadays even operating systems, operations are done in a robotic operations, right? So those procedures, if they are not, if there is a malfunction there, it can definitely cause damage to the human body, right? So software is now dominated the entire world. In every piece of work that we do is dominated by software, and software problems can be very, very hazardous. So Graydon Hoare was inspired by this, not only by this elevator incident, he was thinking around this direction. He's like, hey, can we resolve all these problems at compile time? Then, really in the field, right? That was his major motivation to think. So he started a project called Rust Project as a personal project. His goal was a safer systems programming without sacrificing performance that C offers. So similarly what happened, so Mozilla also was undergoing lot of challenges. So in mid 2000s, Firefox was one of the most world's complex C++ applications. Generally a browser had to do parsing HTML, CSS, execute JavaScript. It had to render graphics and fonts, play audio, play video. It had to manage network. It has to run, had to run multiple processes and threads, right? So all of this in Mozilla at that time was written in C++, which actually offered excellent performance but were prone to so many memory safety issues. And the problems they were seeing is like, all common problems like buffer overflows, use after free errors, dangling pointers, double freeze, data errors, memory corruption, etc. Right? So all of them became security issues. And any malicious web page could exploit memory bugs in the code. Right. So then what happened? So they hired Graydon Hoare. So Graydon Hoare was not hired as a normal engineer, to contribute to a working project. So they had an agenda behind it. So they wanted to have an experimental project called Servo. They trusted Rust and Graydon Hoare's project ideas, and they wanted to give it a try. And so Graydon Hoare personally led this project. The name was called Servo, and it was a research project. And in 2015, so and after the project was done, basically he did a demo internally, and the best part was that it was so good. It was so good, and it was better than the released version of Firefox. So they released Rust 1.0 in 2015, and some part of Firefox was, they kept on changing. They kept on small components of Firefox were replaced by Rust. Around 2.5 years they took to have replaced Firefox with the servo components, right? Adopted. So and it became very popular. From 2015 to present, there is a lot of community growth. It's been adopted by so many companies, and now it is in open source. And now, like people who really learn Rust, they definitely after learning Rust, they rank it as the most loved language. So from a community growth point of view, there are two things here. The Rust project is responsible for technical decision making, right? So if you want to add any features to Rust, there is something called request for comments, RFCs. You can propose a RFC, and that undergoes peer reviews and strict reviews, and if it is accepted, the feature is implemented and released. Okay. And Rust Foundation also is there. It's a non-profit organization. It's helped to build and support Rust. So all the legal support, financial support, trademark management, community programs, everything it's decided by the Rust Foundation. So why did Graydon Hoare name the language as Rust, right? So Graydon Hoare says that so it was not a single explanation, but he did say that he added this after fungi, right? Rust was added after the name fungi was named after the rust fungi. So why did he name that? Because these fungi, according to Graydon Hoare, were extremely great creatures. because they were over engineered for survival, means they have extra capabilities to survive in any environment, right? In harsh environments they can survive, and they are on variety of hosts, and they have surprisingly long complex life cycles, and they persist for long periods. So he wanted a software which is which is free from decay, and can adapt to any host and survive all the harsh conditions, right? That's why he named it as Rust. So Rust is basically, as we discussed, you know, it is a solution to all the memory bugs like null pointers, buffer overflows, data races, undefined behavior. Okay, and the goal was basically to have safety without losing performance. So in case of C and C++, there are a lot of tools. So a lot of tools, runtime tools, and even compile time tools like Coverity, which is a compile time tool, and we have runtime tools like Valgrind, address sanitizers, leak sanitizers, undefined behavior sanitizer, memory sanitizer, thread sanitizer, electric fence, GDBs, LLDBs, Visual Studio debuggers, right? E-fence, electric fence, doctor memory. So all of this we have, like lot of tools, and many of us would have at least used GDB, right? So these tools are designed to attack problems in runtime in the field. But how much can we invest? How much can we invest in debugging, right? The problem has occurred in the field, and then we have to resolve. But here in this case of Rust, all the problems, most of them are addressed at compile time. Okay, they doesn't even go to runtime. So Rust removes the entire class of bugs before the program runs. That was Gradenhore's idea to prevent memory issues at compile time. Okay, so I think that's enough for this video. So we will actually learn about Rust, compilation model, and how to install Rust and program Rust in the next next record.